Hello there, YouTube. We're making another mini grinder. This one took a little bit different parts. This just has a 1/4-inch screw in here. It's an arbor out of you put a drill to put cheap cutter blades, which I don't necessarily like, but it'll probably have just a plastic disc on it for sanding. It'll probably just have a disc on here, which is bigger than this with the screw holding it. It'll just be for sanding mostly, because the other one has actual 1/4-inch shaft where my stones go over. I rolled a piece of copper about 1 inch wide, not about 1.5 inches long. I rolled it and formed it over a drift punch. The shaft of this motor didn't have a flat spot, so I ground one. This didn't have a flat spot, so I ground one. This looks a little off when you turn it, but it looks promising. We'll whip it on here. I don't want to crank it all up. It's not too bad. Unless you had an actual arbor or something machined on a lathe. I mean, this is just homemade. Get way up there, it kind of squeals, so I oiled it. And then it does kind of go off wobble. You'll see it. Got that JB Quick Weld in there, which is not fully cured. It takes 4 hours. It's in 2 hours. But I think it's going to flex because it was 105, 110 degrees here, and I used on the other one, and it'll flex. It gets rubbery. It's not a steel hardened. I need a better, all I need is a better stuff to use, because that stuff all it is plastic, and it's going to bend. I've seen it here when it's hot and it bends. You can see what it does. It tries to flex. You can't go by the side because that stuff's uneven. Like the copper I wrap. You really can't go by anything on the side. All you can go by is the center of the bolt hole. Now I've got a little wobble back. That's my fault. This will not come off without taking the motor apart because there's nuts in here. I'm glad I just didn't keep unscrewing it and have them in there and have to tear the motor apart, which I can do. This one is a little bit different than the old ones off the white sewing machine. This is 140 watts. The other one's 130 watts, 1.3 amps. Well, unless I go to my book and look it up, I can't do the math on it, on electricity. I had it in my mind one time when I was studying years ago on it, but if it's more watts, it's probably more amps. The other one's 1.3 amps, 130 watts. AC/DC. These are a brushed motor. I am positive. Yes, these are brushed motors. I'm going to hook this one up with the foot pedal, if it still operates, instead of the Variac. So we'll put a bolt or something in there, some kind of adjustment knob where the foot pedal was. I can mount it off on the side of my desk and just turn the knob to get what speed I want. We're going to see how it operates that way. So we may not post this video till it's all totally assembled. But here you get the idea. These screws wouldn't come out of here. The other one I like because I had a screw here and here. There was just the threads. It was like a number 8 machine screw. But I will build something for this to mount to. You don't want to weld in this. I don't want any heat on here, any electrical going in the motor. So whatever I build, this is just going to bolt onto. I can always drill any hole I want. It's got a slot. So that's the end of this part of this video. I don't want to get too long on this project. Thanks for watching. Stay tuned for more. Okay, we coated it with this stuff. This stuff mixes together like clay, epoxy. And I know it's really hard stuff. I would put it over strength-wise. It's got to be harder than that quick weld stuff I used. I lost part of the directions. It has silica stuff in it. It is really hard stuff. This has been several hours. It cures pretty rock hard about an hour or so. I've used everything from a little homemade tool to lay this stuff smooth to different grits of emery paper to sandpaper to put this stuff on here. It's really hard. This is what I should have used on my other one, because when it gets hot, this flexes. I'm going to wind it up again here. It's hard to hold this still. Maybe I can do it like this. It will start flexing after a while. I'll never run it this high. That's wide open. That's anywhere from 50 to 60 volts, probably half. It's actually better than my other one. You're going to have some vibration. It's never going to be perfect. Plus it's bigger outer on the end because the piece got bigger. So I tried tapering a little bit. But that's how I did it. I didn't have any more little tubing. Said you had tubing, it was quarter inch inside diameter. I showed how I put that together. I ground a flat spot because the motor didn't have one. It's like the other one. I ground a flat spot on the arbor piece. That way it makes kind of a flat spot. It doesn't want to spin on the shaft. This will never really want to spin because that's all hardened. But I would recommend using like quick weld or something inside that pipe. You want it gooey, you want it to form around there. I made a piece out of copper. I formed it. It did take a while, squeezing it with pliers, hammering it. If I could get this to go real slow. That's not bad. You're going to have some clay in your bushings. Another thing what I'll do is I use something to touch it with. If you kind of feel the bump leaving and going away, it's not real soft, smooth, you know it's out of wobble. It's kind of the way they Redneck Engineering how to balance the drive shaft in a car. I was seeing the guy slammed the wrench down on there and he listens to feels the wrench vibrating. That does make a little bit of a squeak. And then you won't hear it. The motor goes up. But the drive shaft is hollow. You'll hear that banging in there if it's out of whack in one spot. It's good enough for me. This is about the speed it'll be run. It'll never really be over this speed, so it's whatever I put on there if it's not balanced. These motors are pretty cheap. It'd be worth going in somewhere. I mean, especially if they'll show you that the sewing machine works in the foot pedal. I mean, if that's all you want off it, out of someone's trash. I have seen where they've epoxied a quarter-inch drive socket. Some of those have a hole in there. I don't know what size, whether it was a quarter-inch socket or not, but they epoxied it. If you hunt on YouTube, you'll find it. They epoxied it over the shaft, left the square drive, and they made a little mini wood lathe. I'm not really into woodworking, but I would be on my way to making a wood lathe if I'd done that, because they chucked it in there, and then they carved the wood to fit in there. But you can make another piece to go on your little homemade lathe. But this is good enough. I don't want to make this too long, but I want to show enough of this that's balanced pretty good. That's about as far as I'll ever run it. The sewing machine was never designed to run the motor full blast. I'd like to see somebody sew that fast. I'm shaking, can't hold the thing straight. Let's get it. I'm looking at the hole where the bolt goes. Not to brag, but I think I did pretty good on that. I lucked out. I kept moving that though when that stuff was curing. When you see the film clip that I had that stuff, it wasn't fully cured yet. I sat there and womped on it and moved it around and tapped it and stuff before I applied this. So I made it better before this went on there, or this would just be still wobbly. I think this kind of helped balance it out too with the mass to it. We'll find out when we put a sanding disc or something on it.